Okay, so today we are going to add and subtract polynomials. To be able to add and subtract polynomials, they have to have the same base and the same exponent. If they don't have the same base and the same exponent, you can't add or subtract them. Some examples of like terms, 7x and 7x. They both have an x as the base, and they both have that invisible 1 as their exponent. Another example would be a squared and a squared. If you were to add them together, 8 plus 17 is 25 a squareds. The last one, xy and xy, they both are the same base and they both have that invisible exponent of 1. So they are like terms. If they by chance wrote it xy, yx, they are technically the same. They are like terms because this one can be rewritten as xy. They're the same by the commutative property. Some examples of not like terms. X and y are not the same base. They're two different letters. You cannot add them together. X cubed and x squared. X's are the same, but our 3 and our 2 are different, so you cannot add and subtract them. And then obviously x and w are not the same letters. Some examples of how to add polynomials, they'll be find the sum. They'll be written as fx, g of x. And then the same thing for subtracting. Difference means subtraction. They'll have that negative subtraction symbol there to subtract, and then f minus g of x. X is the first two. All right, when we add and subtract polynomials, we always want to rewrite them without the parentheses first before we do anything else. We can do that by just rewriting the first one. So 4x squared minus 9x plus 3. The second one, the way to rewrite that one, there's technically an invisible 1 there. And this will be super helpful when we do subtracting. 1 times negative 2x squared is just negative 2x squared. 1 times negative 5x is negative 5x. And 1 times negative 6 is negative 6. So technically when you add polynomials, you can just rewrite the second set of parentheses without the parentheses. All right, so now to combine like terms, we have to find ones with the same exponents. So we have to find ones with the same exponents and the same base. So when we write it in standard form, remember highest degree, the x squared is my highest degree, and I have another x squared here. So negative or 4x squared minus 2x squared is 2x squared. And then I have a negative 9x and a negative 5x. So when you add those two together, you get negative 14x, and then my last two is a plus 3 and a minus 6, which makes it negative 3. I am in standard order. Leading exponent is 2, 1, 0, so this guy is my final answer when I simplify and add my polynomials. When I subtract, you're always allowed to drop the first parentheses, just like adding. However, you have to be careful in the next step. Remember that 1 right there? There's an invisible 1 here too. So when you distribute that negative 1 into everything, it becomes negative a cubed. Negative 1 times negative 3a is a positive 3a, and negative 1 times negative and positive 2 is a negative 2. So my second set of parentheses, every sign changed. That a cubed became a negative a cubed. That negative 3a became a positive 3a, and that positive 2 became negative. So you have to be careful to subtract, to drop the parentheses, every sign on the side each. With the beginning again. My exponent is 3, so 2a cubed has a friend of negative a cubed. And if we remember, there's an invisible 1 right there. So 2 minus 1 is just 1, so 1a cubed. Now I can look at my next leading exponent, which is just a, so 5a and 3a makes it 8a. And then my last two are just negative 7 and negative 2, which makes it a negative 9. The leading exponent is first, so we're in standard form. We don't need the 1, so it can also be written like that. All right, go ahead and try some of the examples on the second page by yourself. There is an answer key on Classroom for you. I'm going to jump to number 7, 8, and 9. So 7, 8, and 9 is using the same things as the top, except it's in words. So it's telling you subtract this from that. So I'm taking this and I'm subtracting all of this from it. So you technically have to write that 8x cubed minus 4x squared plus 3x minus 1 first, and then subtract the 2x cubed plus 3x squared minus 6x plus 4 afterwards. And then from there, parentheses drop. To be able to drop the second set of parentheses, every sign needs to change on the inside. So negative and a positive makes it a negative 3x squared. Negative and negative makes that a positive 6x. And that positive 4 becomes a negative 4. Then we just start combining like terms. When there's this many numbers, I would probably start canceling out. Oh, this should say 3x squared as I do it. So 8x cubed and 2x cubed. When you subtract the 2, it gets you 6x cubed, negative 4x squared, and negative 3x squared will get you a negative 7x squared. And then those cancel. I can throw them out. 3x and 6x makes a 9x, and a negative 1 and a negative 4 makes it a negative 5, making that my final answer. And you same thing for this too. This guy gets written first. Subtract x squared plus 3x minus 2 there. All in the first set of parentheses drop. And then that becomes that negative minus x plus 2. Start combining terms. Nothing to go. I have an x cubed, so I rewrite. Now I have a negative x squared and x squared, making it negative 2x squared. Go away. A positive x and a negative 3x cancel. You don't have to rewrite it. And 4 and 2 gets you 6, making the final answer. Number 9's answer will be in Google Classroom also with the answer key to the back. So sometimes they're going to look like this. They give you a polynomial f of x, polynomial g of x, polynomial h of x, and then they've rewritten in these forms. The first one is just telling you what polynomial f of x. Subtract the h of x 1. So f of x is at the top here. So 9x squared is 4x plus 2. And then subtract my h of x, which is this guy right here, negative 2x squared is 3x minus 10. And try that one for yourself. And then come check your answer. Okay. Number 2 is just saying sum, and we remember sum means add. So I'm going to take my f of x, which you have as 9x squared minus 4x plus 2, and I'm going to add my g of x to it, which is 3x 1. Go ahead, try it by yourself. I'm going to throw it down right here. That is your answer. Okay, the last two. This one's fine. F minus g of x. So it's technically kind of like the distributive property. I have an f of x minus my g of x, which is just like example 1. So f of x is 9x squared minus 4x plus 2 minus my g of x, which is 3x minus 1. You can solve that for yourself. The answer will show up on the classroom. The last one just says g of x plus h of x. So g of x is 3x minus 1. That means I'm adding my h of x, which is negative 2x squared plus 3x minus 10. Okay, go ahead and check your answers on Google Classroom. Come see me for extra help whenever you need it.